What up, YouTube? I'm back at it again, and today I saw this SAT math question and thought it was interesting, so I wanted to solve it. For those of you out there who might have any issues, maybe facing these sort of problems, I wanted to solve it and put it out there for you guys. So the question asks, and this I'm talking about question 25. And it asks, in the xy plane, the graph of the equation y is equal to negative x squared plus 9x minus 100 intersects the line y equal to c at exactly 1 point. What is the value of c? And then we have the following answer options. So to solve this this problem, typically if you wanted to find an intersect, you would set the two equations equal to each other and solve for x. And so let's go about doing the same thing and see what we get. So we get the 9x minus 100, and then we set it equal to c. Once we do that, one thing we could do is we can rearrange, or we can move either the left side of the equal sign to the right side, or we can move the right side to the left side. To make the equation, simpler on ourselves, I'm gonna just move everything on the left side to the right side. So I'm gonna add 100 here. I'm going to subtract this 9x, and then I'm going to add an x squared. So when we do all that and we rearrange this this equation, it looks more like this x squared. Mind you, I'm moving everything on the left side of the equal sign to the right. And so now the 9x become negative 9x. The negative 100 becomes positive 100. And the c would just be where it was, so it'll just be added to this 100. So now this is the equation that we have. And it says at least the problem is asking us what is the value of c. Okay, so let me see. So, and then it says that intersects at exactly 1 point. So typically, once we've arranged the equation, the quadratic equation, in this format, we can FOIL and then set the individual foiling results to 0 and then solve for our x. But we have an interesting situation here where we need to get only the solution needs to be exactly 1, which means that the individual if we were to FOIL this, the two foiling would result in exactly one answer. So the answer would be the same. And so typically when you have something like this, if you cannot see a way forward by foiling, there's the quadratic formula that we can use, which looks something like this. It looks like negative b plus or minus, and then you have the square root of b squared. Then you have 4ac all this divided by 2a, and this is the quadratic formula. And this would be, it'd be x is equal to this, right? If we were solving for the individual x's, and this will result in two answers, right? Because we have to plus or negative. So whatever this negative b value is, plus or negative, whatever the sole discriminant is, or whatever is under the square root, which will be the b squared minus 4ac. But so typically, if whatever is in if the discriminant turns out to be a positive number, then the solutions to the quadratic equation would be a real solution. But if the discriminant turns out to be negative, then typically you're going to have non-real solutions or imaginary numbers in the solution. And then if the discriminant turns out to be 0, that's the case where because imagine negative b plus or negative 0 will still be negative b, so meaning that your x, this x value would be the same either way, right? So it looks like this is the situation we have here, where the question, or at least one of the sentences, is saying that the y, it says that the graph of the equation y, and then it, negative x squared plus 9x minus 100 intersects the line y equal to c at exactly 1 point. So we're dealing with a case where the discriminant has to be 0 because it is exactly 1 point. So that's the situation that we need to consider here. And so we need to set this discriminant equal to 0 and then solve for c. That's what we're gonna do. And then typically also the regular form goes like this. The regular form of the quadratic equation goes something like this. Okay, it'll just be bx minus c. And so essentially whatever the coefficient for the x squared is, that'll be a. Whatever the coefficient for the x term is, that'll be b. And then whatever the constant is, that'll be c. And so going along with that, we can say that the b squared in this case, mind you, we're using a discriminant, so it'll be b squared minus 4ac. And then we set this as equal to 0. And then we plug in values. So we go up here, we see that we get negative 9, negative 9 squared minus 4 times 1 times the constant, which in this case our constant would just be the whole 100 plus c term. Okay, and so we go ahead and then we set this whole thing equal to 0. Let's not forget that part. So now we go ahead and we get 81 minus 400, because we take this 4, this 1, we'll just ignore the 1. 1 times 4 will just be 4. So we take this 4, multiply by 100, and then we take this same 4, multiply by c. So we get, and then that will also be negative 4 multiplied by c, so it'll be negative 4c. This whole thing is still equal to 0. And then afterwards we combine the 81 and the 400, which should give us negative 319 minus 4ac equal to 0. Now if we want to solve for c, we just need to add the 319 to both sides of the equation to get rid of it in the left side of the equal sign. Then we do the same for the right side of the equal sign. So now the whole equation would look something like negative 4c is equal to positive 319. And then solving for c, we just divide both sides of the equal sign by negative 4. And then c will equal negative 319 divided by 4. So that'll be the value for C. And so it looks like that'll be answer option C. So if you found this material to be interesting or even helpful, do subscribe to the channel and be on the lookout for great content like this. I hope to see you next time. Thank you so much.